Hi everybody. This video is going to talk about special segments of similar triangles. So, if you look on here, we've got several different types of segments that happen in triangles. We've got altitudes, medians, angle bisectors, and then there's also the angle bisector theorem, which we'll talk about at the bottom. But just to start off with, let's talk about these three different types of special segments that can happen in triangles. And let's kind of review the vocabulary that goes along with them as well. So remember, an altitude makes a right angle. So QA and UX would be altitudes, and it makes that right angle with the base of the triangle. So that altitude has a right angle. Remember, a median is going to be this QM and this UY. And a median, remember, is where it cuts the base into two congruent parts. So PM is going to be the same length as MR. And TY would be the same length as YW. Or sorry, that's a V. YV. So median cuts the base into two parts and is connected to the opposite vertex. And lastly, an angle bisector, remember, is a line that cuts that top vertex in half. Okay? So it bisects the angle at the top. And so what's important about these three different special segments is that they are proportional to the corresponding sides of a triangle. So if you know you have an altitude, then you can write the length of QA over the length of UW here. So the two pink lines, the altitudes, and you can say they're equal to a ratio of any corresponding sides. So we could say QR over UV. We could say QA over QW equals PR over TV, or we can say QA over UW is equal to PQ over TU. You could pick any set of corresponding sides as your second fraction right here. Okay? So let's look at the next one. It says the medians are proportional to the corresponding sides. So you could say QM over UY is congruent to or equal to, and then you just pick corresponding sides. So QR over UV would be 1. You could say PQ over TU, or you could say PR over TV. Any of those full lengths, that would make them proportional to those sides. And lastly, the angle bisectors, same concept. Sorry, this is A. Oh no, it's Q. Sorry. So we would say QB over UX equals, and then we could pick another set of corresponding sides, like QR over UV. But that's not the only one we could pick. We could have said the same thing, but instead said PR over TV or PQ over TU. Okay? So their corresponding sides are going to be proportional to the ratio of those special segments. Angle bisectors have another special property. So not only is this angle bisector going to be proportional to corresponding sides in separate triangles, they also have a special property within one triangle itself. So as you can see here, we have an angle bisector, CD. That's our angle bisector. And what it does is it separates it into two opposite segments. It says angle bisector to triangle separates the opposite side into segments that have the same ratio as the other two sides. Okay, so if you look at saying AD over DB, so AD over DB, let's pick a different color, so AD over DB is equal to, and then AC, since it's on top I'm going to make it pink, over BC, which is right there. So what this is saying is, it's the two that go on top are the ones that have the vertex A, and the two that go on bottom are the ones that have the vertex B. Okay? So we say AD over DB is equal to AC over BC. Okay? So we're going to use these four properties to answer some questions on the inside. Fold it in half. Alright, and let's look at some of these ones on the inside. So in example 1, it says in the figure, and it's supposed to say triangle ABC and triangle XYZ. Triangle ABC is similar to triangle XYZ. Find the value of X. So right now, what do we notice we have? Well, we have, if you see, it's showing that they're angle bisectors. So these are angle bisectors. Okay, so we can say that the ratio of the angle bisectors is congruent to the ratio of another corresponding side on the triangle. So we can say 10 over 8, so we just make a fraction of the yellow lines, 10 over 8, those are the angle bisectors, is equal to, and now 24, what does it correspond with? X. So we would say 24 over X, and then we just cross multiply and solve. So we get 10x equals, let's do 8 times 24, 192, and then we divide by 10, so x equals 19.2. Okay, so it's actually really simple. It's just once again writing ratios of sides and solving proportions, which is why I made a big deal about that last test that we took, making sure that we understood exactly what it was saying. Alright, let's look at example 2. So example 2, we have a couple of special segments, and which ones are these special segments? So if you notice the markings, they're saying that this is congruent to this, so that must mean that they are medians. Alright, so on example 2 we have medians. So we know that 20 goes with X, and then we can just mark up some corresponding sides, 36 and 18. So 20 over X equals 36 over 18, and then you just go ahead and solve it. Don't know why I put equals there. So we get 36x equals, and then 20 times 18 is 360. Divide by our 36 on both sides. X equals 10. The weirdest looking 10 I've ever written. Okay, easy enough. Alright, example 3. What kind of special segment do we have here? Now this time the segment is not inside the triangle, it's actually outside the triangle, but it is perpendicular to the base, and that special segment was the altitude, the one with the perpendicular lines. So we're going to say these special segments, so x goes with 7. Okay, so this time we have altitudes. Okay, so x goes with 7 as, and then we just pick corresponding sides, so I can say 10 goes with 8. And then you just solve it. So you get 70 equals 8x, divide by 8 on both sides, and then x equals, I don't know what 70 divided by 8 is, 8.75. Okay, it's supposed to be easy, guys, not meant to be super duper challenging. Let's look at example 4. Example 4 follows that we only have one triangle here, so we're probably going to use this extra thing we learned about angle bisectors. So remember, it's the segments with vertex A, so it's the segments here, over the segments with vertex B. And remember, we're going to start with the same bottom part on each one. So looking here, we have our angle bisector. It might help to just kind of draw the color. I don't know. I prefer using color. It helps my brain organize information. So we're going to say x over 6 equals, and then 15 over 9. So remember, it's just the part on the one. I would take the two little pieces the angle bisector cuts. That's going to be our first fraction, x over 6, and then 15 over 9. And then just multiply. 9x equals 15 times 6, which I think is 60. No, it's more than that. 90. And then divide by 9, so x equals 10. Okay. Alright. Okay guys, these were all some pretty simplistic examples. X was our length. We didn't have any expressions, but if you look on the worksheet, you're going to have some with expressions. So just remember, when you write your proportions, that you need to do those parentheses and then distribute. Okay? Alright, thanks for watching. Have a wonderful day.